All right, welcome guys. Excuse me. Sorry, in this video we are going to be finally moving on to chapter 7. And chapter 7 has to do with similar polygons, but before we even really jump into the geometry of it, we are just going to start off talking about a little bit of algebra with ratios and proportions in 7.1. So 7.1 really focuses on ratios. We'll introduce proportions at the end. And then 7.2 will continue that work with proportions. So without further ado, let's get going. All right, so what is a ratio? So the ratio of one number to another is often expressed as a simplified fraction. All right, and you've probably seen these ratios before. This first one we're going to start off with is just, well, let's find the ratio of the number 8 to the number 12, the ratio of 8 to 12. And again, this tells us that ratios are often written or expressed as a simplified fraction. So let's start just by writing 8 over 12. We'll take that first number, put it in the numerator, the top of the fraction, and then we'll take that second number and put it in the denominator or the bottom of the fraction. So now we have 8 over 12. Well, we want to simplify this. We can see that both the numerator and the denominator have a common factor, a greatest common factor of 4. So we'll divide each of those by 4. 8/12 is equal to 2/3. All right, so this is really going to be our simplified ratio of the number 8 to 12. It's just 2/3. So all we did here was just simplify a fraction. This is something that you've probably been doing for a while. Another way that you might see these ratios expressed to start is you might see it written as 8:12. That is also written as 8 to 12. So you can think of this colon as just the word 2. All right, 8 to 12. And then again, we simplify that ratio by just simplifying a fraction as we normally would. All right, and sometimes these ratios might include variables, and that's okay. We know how to work with variables and fractions, hopefully. This might be a little bit of a reminder of Algebra 1 for us. So in this ratio, we have 15ab to 3a squared. So let's just start by writing this as a fraction. 15ab over 3a squared. So whenever you have variables now, we're going to start off by treating the variables just like we would with a regular number. Well, we look at the constant values. So we look at this 15, we look at this 3, our coefficients of the variables, that big number that's attached to the variables, and we see if we can simplify those first. 15 over 3, we definitely can simplify as 5 over 1. So I'm just going to put the 5 in the numerator. No need to put a 1 in the denominator. That's already implied, right? We don't have to say 1 times a squared. All right, now how do we simplify a over a squared? This is something that maybe we don't really remember from Algebra 1. Hopefully we do. But if we forget, let's remember that a is the same thing as a to the first power. And, well, what do we do when we're dividing two variables, the same variable, two exponents? Well, we are going to subtract. Okay, we subtract their exponents. And then we just write it wherever the higher exponent was. So in this case, my higher exponent was in the denominator, a squared, and a to the first was in the numerator. Well, 2 minus 1 gives me 1 over a to the first in the denominator. All right, and again, a to the first is just the same thing as a. All right, so when I simplify this a over a squared, this little segment right here, that gives me just an a in the denominator. And then I have a b in the numerator, nothing in the denominator, so that b will just stay in the numerator. So simplifying that expression with variables just winds up as 5b over a. Again, hopefully that was a little bit of an algebra review for you. All right, and let's just get into just one more geometry problem because obviously this is important. We got to be able to do this. So this problem tells us the ratio of measures of two complementary angles is 2 to 3. Find the measure of each angle. So these problems can be a little bit tricky. All right, I know I'm going to have two angles. They add up to equal 90. That's what complementary means. So two angles that are adding up to 90, their ratio is 2 to 3. Well, what I'm going to do in this problem is just say, well, I know that I divided each of these by its greatest common factor to get it down to 2 to 3, right? I divided it by some greatest common factor to simplify the ratio down to 2 to 3. Well, let's say that greatest common factor, we'll just say that the greatest common factor was x. So that ratio of 2 to 3, I could say, is just the simplified version of 2x to 3x. Well, when I add 2x and 3x together, it should give me 90 because, again, these are complementary angles. So 2x plus 3x should be equal to 90. That's 5x is equal to 90, telling me that x, which was my greatest common factor, x should be equal to 90 divided by 5 is 18. All right, then it says find the measure of each angle. Well, the measure of my first angle was 36, right? 2 times 18. And the measure of my second angle was 3 times 18, which is 54. And if we want to check our answer, well, let's just make sure. 36 plus 54, that's equal to 90. Great. So I know I did at least part of it, right? Okay, 36 plus 54 is 90, so that's good. And now let's just check that those are in the ratio of 2 to 3. So again, 36 over 54. I know my greatest common factor should be 18. Well, 36 divided by 18 is 2. 54 divided by 18 is 3. Perfect. So found the measures of my angles, and I know my greatest common factor of x was really equal to 18. And lastly, we're just going to introduce proportions here. So a proportion is really just an equation that states that two ratios are equal to each other. So we could say the ratio of 3 to 4 is equal to the ratio of 12 to 16. It's easy to see. 3/4 equals 12/16. Yeah, right, we've worked with fractions before. We know that's true. So this proportion is just this equation that tells me they're equal to each other. And we're going to touch more on properties of proportions in 7.2.